Hey guys, we shall solve another problem on LeetCode now. The problem is given two strings word1 or word2, return the minimum number of operations required to convert word1 to word2. So the three operations which we can perform on the characters in the word are either insertion, deletion or replacement of a character. So the problem here is that given a word, you have to convert this word to the word to, and you have to do this with the minimum possible operations. So this is the example they have given. I'll consider this example and solve the problem now. So how do we solve this problem? For solving this problem, we need a memo table. What does it mean, memo table? So memo table is nothing but it's a type of data structure that is used to store or it's used to store and organize the information within the program, and this memo table can be of any type. It can be array, list or dictionaries. So yeah, we'll be using this memo table in this problem now. So if you want to use the memo table, at first we need to get the dimension of the table, right? How do we get to know the dimension of the table? We have two words here, word1 and word2. So word1 is the dimension of the memo table will be corresponding to these words. So the rows will be the length of the word 2 plus 1, and column dimension will be the length of the word 1 plus 1. Why am I telling this additional 1 is because in the table you will have to dedicate a cell for an empty string, because these strings need not be always the collection of characters, right? It can be empty as well, so we need to dedicate a cell in the table for an empty string as well. That's why we add 1. So rows is the length of the word 2 plus 1 and column is the length of the word 1 plus 1. So the dimension of the memo table, we have drawn this table here, and dimension of it will be length of the word 2 is 3 plus 1 4, 4 cross. Length of the word 1 is 5, 5 plus 1 6. It will be 4 cross 6, 4 cross 6. So as I said, the initial cell will be dedicated to the empty string. So the very first row and very first column, the initial cell will be empty string. Next, the word 2 for rows and word 1 length for the columns we have given. So word 1 for the columns, that is HORSC. So now how do we fill in this table? So at first we'll consider the first row and first column. We'll fill the values in the first row and first column. To fill the values for the first column, what we need to do is, how do we fill this cell? So this is the empty string. What is the number of steps you have to perform to convert this empty string to an empty string? So input is empty string and output is empty string. Do we need to perform any operation on this? No, we can keep it as it is. So we need not to perform any operation on this. So the number of operations that you need to perform is 0. Next, go to the second row, first column. Here the input is empty and the output is R. You have to convert an empty string to a string of character R. So how do we do that? If there is an empty string, if you want to convert into a string of R, then you have to insert the character R. So that means you have to perform one insertion operation over here. So the number of operations performing in this combination is 1. Again empty string to O, again empty string to not O, empty string to RO. What it will be? It will be 2 operations, because one for each character you need to perform an insertion. So insertion for each character, total of 2 insertion operations you need to perform. Next, empty string to ROS. How many insertions? 3 insertions. One for R, one for O and another for S. So we have filled the first column. Now we shall fill the first row of the table. So the given input is H. We want to convert into an empty string. How do we convert into an empty string? Just by deletion of H. That means you have to perform a deletion operation. How many deletion operation? 1. Next again, HO to S. So for HO to S, HO to empty string, how many deletion operations we have to perform? 2, 1 for each. So total of 2 deletion operations. Then again HOR to S, how many deletion operations? 3 deletion operations. Then HORS to empty string, you have to perform 4 deletion operations, 1 for each, and similarly for the entire string you have to perform the 5 deletion operations. So we have filled the first row and first column of the table. Now how do we fill in the remaining columns? Also, why do we need to fill in the columns? How do we calculate the minimum operation we need to perform? That I will tell you in the later part. So now let's focus on how to fill in the remaining columns. So we'll consider this cell first. For filling the remaining columns, you have to initialize 3 variables, I, D and R. So this I is nothing but insertion, D is nothing but deletion, R is nothing but replacement, which they have told in the question that you can perform either of the 3 operations on a character, right? So we'll consider this cell. I is nothing but insertion operation. That value will be the immediate top value for this cell. So immediate top value. D deletion will be the immediate left value for the given cell. Immediate left value. And for replacement, it will be the top left value, immediate top left value. That is nothing but the diagonal value. For this cell, the diagonal value will be the replacement value. So it will be top left. So after this, what you have to find is minimum of all these 3. I, D and R. Minimum of I, D, R. You do that, and for that minimum value, you add 1 and that will be equal to the cell value. So for filling this cell, what you have to perform is, you have to initialize 3 variables, insertion, deletion and replacement. Insertion is done by the immediate top value, insertion value will be the initialization, the deletion initialization will be the immediate left value, and replacement will be the immediate top left value, that is diagonal value. And you find the minimum of these values, you do additional 1 for this, and that will be the cell value. Why do we need to perform additional 1? That I shall explain. So let's do the operation over here. Insertion, how many? Insertion is a top immediate top value, that is 1. So insertion will be 1. Deletion is the immediate left, again it will be 1. For replacement, top left, that is 0. So minimum of 1, 1, 0 is what? Is nothing but 0. So 0 plus 1, how much? 1. So 1 is the cell value. Now you logically, if you think, like it means if you see the character here, at first you have the string as 0, empty string. So we'll simply take in the value minimum operation. At first it will be 0, right? See this 0. So empty string 0. Then you what to do? We go to the first character of the first word and first character of the second word. Compare those two. So here what we have to perform is, we have to replace H by R. You have to convert H into R. How do we do that? We do that by replacing H with R. That means you're performing one replacement operation over here. So the minimum is 0. You have to perform one operation. So additional 1 will become, and total how much it become? 1. So 1 is the minimum operation, current minimum operation. So you are doing nothing but what you are doing is, you are adding extra 1 to the previous minimum operation value if we are performing either of the 3 operations, insertion, deletion or replacement. Here you are performing the replacement, you have to convert H to R. So you are you're performing one replacement operation, that's why you're incrementing the minimum operation value by 1 to the previous value. Previous value is 0. So if you observe this previous 0, we could find the 0 value over in the top left diagonal. That is nothing but replacement. So what are we doing technically is we take in these three values, find the minimum of that is 0. That minimum value will always be the minimum operation of the previous value, previous cases. So here 0 is the minimum one. Then you add 1 to that. Why you add 1? Because you're performing a replacement operation, one of the either of these operations. So it will increment to 1. Next we'll go to the second column, a third row, second row, third column. So 0 is the input and R is output. You have to convert 0 to R. That means you have to replace 0 with R. Again, you are performing a replacement operation, right? So if you are performing one replacement operation, it means you're performing one operation. This in your minimum operation value will again increment by 1 and it will become 2. It will become 2 over here. So okay, if you go through with the algorithm method, minimum of I is nothing but 2, D is 1, R is top left 1. So minimum of all three is 1, 1, 2 is 1. So 1 plus 1, 2. 2 is the cell value. So you are inheriting the minimum operation value which was initialized earlier over here and you are incrementing it by 1. Why are we incrementing it by 1 means we are performing a replacement operation here. That's why. Now comes the special case. Here you can see input is R and the output is R, which means that you need not to perform any operation on this. We can keep it as it is. This is a zero replacement condition. Zero replacement condition. So what do we need to perform anything over here? No. At that time what will you do? We'll keep the minimum operation value as it is. You're not performing any operation, so you're not incrementing it by 1 as well because you're not doing any operation. You're keeping the previous minimum operation value in the current cell. So that means this previous minimum operation from this algorithm, from where does it come? It's nothing but the top left value. Top left is the diagonal value. We're taking the top left value to the current cell. That means you're not incrementing it by 1 because you're not performing any of the operation. You're just reinitializing the previous minimum operation value. Hence, in this program, there are mainly two cases. One is zero replacement case. That is what R to R we have found out. Like we are not doing any operations. We are not incrementing it by any value, one value. And we are just reinitializing the previous minimum operation value in the current cell. If this is not a zero replacement case, then you will go to this situation where you will have to perform an insertion operation where you perform in the very first column where empty string to R, empty string to RO, empty string to ROS, or you will have to perform deletion operation which we performed in the first row from H to empty string, HO to empty string, HOR to empty string. Either insertion or deletion, else replacement will has to be done in the remaining cells where if you want to convert H to R, O to R, then you have to perform the replacement operation. If this is the case, then you find the minimum of 3 and you add 1 to that. We add 1 because it indicates that you are performing an operation. So you have to increment the minimum operation value by 1 and that will be the current cell value. So we'll do the same method for entire cell now. You can see here input is S and output is R. So conversion of S to R means you're replacing S by R. Hence we'll perform this operation. Minimum of I, D, R. I is immediate top 4. D means immediate left, that is 2. Next replacement is immediate top left, that is nothing but diagonal value 3. So minimum of 2, 3, 4 is nothing but 2. For 2 you add 1, that will be the cell value. For 2 plus 1 it will be 3. Similarly we'll do it for all the other cells. Here conversion of 3 to R, replacing E by R. Again you have to perform this operation. So minimum of 3, 4, 5 is 3. So 3 plus 1 it will be 4. Here H should be replaced by O. Here this is the conversion. So again the minimum of 1 1 2 is 1, 1 plus 1 it will be 2. Here if you see O to O, so it will be 0 replacement case. So in such case you need not to increment any value or these operator need not perform, just inherit the top left value to the current cell. So it will be 1 top left. Then R2O, yes, you have to perform replacement operation. Minimum of 1 to 2 is 1, 1 plus 1, 2. Then again S2O, yes, replacement operation. Minimum of 2 to 3 is 2, 2 plus 1, 3. Then E2O, yes, we have to perform replacement operation. So minimum of 3, 3, 4 is 3, 3 plus 1, 4. Then we'll go to the last row. So H to S. So replacement has to be done of H to S. So that is nothing but minimum of 2 to 3. 2 plus 1. Minimum is 2. 2 plus 1. 3. Again O to S. You have to find the minimum. 1, 2, 3. Minimum is 1. 1 plus 1. It will be 2. R to S. Yeah, we have to perform replacement here. So minimum of 2, 1, 2 is 1. 1 plus 1. 2. Here S to S. S to S means you need not to perform any operation. So it's a 0 replacement case. You are just inheriting the top left value, that is nothing but 2. Then E to S, yes, E replacement has been done. Either of the 3 operations is being performed here. So minimum of 2, 3, 4 is 2. So 2 plus 1, cell value will be 3. So this is the final minimum operation value. So how do we solve this problem? We just initialize the table first and we find the length of the words, and yeah, we start filling the first row and first column values. After filling that, the remaining part has to be filled either by the 0 replacement case, or if you are performing either of the 3 operations, then we'll perform this minimum of IDR, and for that you add one value and that will be the current cell value. So 3 is the minimum operation that you need to perform over here. Okay, now we shall solve the problem. So at first we need to find out the length of each word, right? So we'll initialize int p equal to word1 dot length. Next int q equal to word2 dot length. So we have got the length of word and word 2, so that we can now declare the memo table as well. So how do we declare? Int memo equal to new int of the length of the p plus 1 and then q plus 1. Why are we adding 1 here? As I said, this is for the empty string. So rows into columns. So we are done with the initialization, all the initializations. Next we will update the first row. Updating first row. So for that we need a for loop int I equal to 1, I lesser than equal to q. Why are we taking q? First row means length of the word total you have to get, and I plus plus nothing you have to do is memo of 0 comma I equal to I. You are just going to the for loop and initializing the value of the I itself in the memo table cell entries of the first row. Similarly, you do it for the first column as well. So updating the first column for int I j equal to 1, j lesser than or equal to p, j plus plus memo of j and 0. So you are updating only the row values as you go down, no? Equal to j. So after you initialize the fill in the values for the first row and first column, the remaining values, how do we do that? For that again you need two for loops, and one case for zero replacement, another case for this insertion, deletion or replacement operation. So for remaining cells, for loop, outer for loop for int I equal to 1, I lesser than equal to p, I plus plus for int j equal to 1, j less than or equal to q, j plus plus outer loop and inner loop, so that you can go through the each cell, and you start with 1 because I have already initialized all the values here. So you start with the first cell indexing. Now we'll consider the first case where you need not to perform any replacement operation like R to R, S to S, O to O. So for zero replacement, if word 1 dot character of I equal to word 2 dot character of j, it should be j minus 1 and I minus 1. Why? Because you're starting from 1, right? So a previous value to that you have to check. Then memo of I comma j is equal to top left. Top left is nothing but, if you consider this cell, top left is nothing but I minus 1 and j minus 1. So memo of I minus 1, then j minus 1. This is one case where no replacement is done. If you need to perform any replacement, then for either of three operations, else what do? You have to initialize the three variables: insertion, deletion and operation. Int insertion equal to, how do we calculate insertion? Immediate top, right? So if you consider this cell, immediate top means j value will become j minus 1. That will become memo of I and j minus 1. Similarly for deletion, it will be memo of immediate left. I value become 1 decremental. So I minus 1 and j. So lastly, replacement will be memo of diagonal value. That is nothing but top left. So I minus 1 and I minus 1, j minus 1. So you will get the diagonal value. Memo of I minus 1 and j minus 1. So after initializing all these values, you have to find the minimum of these values. How do you find the minimum? We have the inbuilt function, right? So int just a second. Yeah, int memo of I comma j equal to math dot minimum of. So we know that minimum is a function in Java. It compares only two values at a time, right? Takes in two values. So what should we do? We have three over here. So at first we'll compare insertion and deletion. We find the minimum of the two, and you assign that value. Compare that minimum with the replacement value. So that total you find the minimum of all the three values. So this is the outer one. We find the minimum of insertion and deletion inside this braces. So for this math dot minimum of insertion comma deletion, so that you find out the minimum of these two, that you compare it with the replacement. You compare it with the replacement. After that you add 1 to the cell value. That will be the value of that cell memo of I comma j. Why do we add that one value? It indicates that you are performing some insertion, deletion or replacement operation. So you have got the memo of I comma j. So at the end, what do we need to return now? We need this value, that is into a memo of p comma q. So return memo of p and q. So what we have performed is we initialize the length of these things, and we declared a memo table with the initialization of the dimension of the word length for rows and columns, then updating the first row and first columns. After filling that, you go to the inside the remaining rows. For this you have two cases. For the remaining you have two cases, either zero replacement or you're performing any of the three operations. Zero replacement, performing any of the three operations. So for zero replacement, you are not performing any incremental value on the minimum operation. So you're not including plus one over. You're just taking the top left diagonal value. That is not known. I comma j will become I minus 1 and j minus 1. I comma j is, if it is this, I minus 1 and j minus 1 will be this cell value. Next, if it is not a zero replacement case, then if you need to perform any of these operations, out of this operation you find the minimum of these things and you add 1 to that. That will be the cell value of memo I comma I and j. And finally you have to return memo of p comma q. That is nothing but the last cell value, which is the minimum number of operations that we need to perform. So we shall run this and check. So you can see that this case has been accepted, and we'll submit it. Yeah, all the test cases have been passed. So it's a problem related to harder part in the problem. So we are using memo table and solving this problem. Hope you guys have understood this. We'll come up with the next problem in the next session. Thank you.